Imagine trying to fight an invisible enemy without knowing its shape. That's what managing AI risk feels like until we build a taxonomy, a language to classify and confront it. From data bias to model drift, from ethical blind spots to systemic failures. Each category tells a story of how intelligence can betray intent. In this section, we map the full terrain of AI risk so leaders can stop reacting and start anticipating. Welcome. This is your host Savit Vittal Salian. We are in the series of AI risk and we are in part 2 of typology and taxonomy. The agenda for the whole series is as shown. We are at part 2. In part 2, the specific topics of the agenda would be as shown. So let's start the journey. Starting off, what's typology and taxonomy? Typology, a classification based on types or patterns. It explains how different things behave or relate based on their characteristics. Think of it as a grouping by kind of behavior. Whereas a systematic hierarchy of categories, taxonomy is organizing things in a structured, layered way, often showing the relationship from general to specific. This is grouping by structure or levels. Let's go deeper to understand this context. So, typology is types for ease of understanding and relation. Typology helps us understand different types or patterns that exist within a domain. Like what kind of things exist here? Example from an AI risk context: bias risk, explainability risk, privacy risk, security risk. Each is a type of AI risk. This is your typology, type of risk. So, what's taxonomy? Think of taxonomy as a tree. Taxonomy builds a structured system or hierarchy of these types, which shows how they are related, how broad or narrow they are, or how they can be grouped. Taxonomy answers how are these things organized or related. Example from a AI risk context perspective, we have technical risk, we have operational risk, we have ethical societal risk, bias, drift, robustness. These are part of technical risk. So bias, drift and robustness are organized under technical risk. Similarly, model misuse, data governance gaps are organized under operational risk. Fairness, transparency, accountability are organized under ethical or societal risk. That's a taxonomy, a map or hierarchical classification of risk. So let's look at an analogy. Here we take example of library versus a book genre. From a typology perspective, it's grouping of books by genre, whether it is fiction, mystery, science. So think through that you are entering a library and you are interested but not very specific on the topic, but you are interested in looking at the options available under mystery or science or fiction. So when you think from that, that's your type of books that you're looking at. You're just identifying the different types here. Whereas in taxonomy, you're organizing, wherein the librarian organizes how these sections, categories and subcategories would be set up. So in typology, here's a type. What type of flavors you would like to have? A sweet flavor, sour flavor, a spicy flavor. But what in spicy? What in sweet? You have hundreds of options in each of this. But the type is the sweetness or sourness or bitterness. That's typology. On a taxonomy, it's about how you're organizing the library, or if you enter a supermarket, how are you organizing it? What will be there in the start entry? What type of organization you want to build up there? Which products, which category of product would be here, or where it would be placed? So once you enter that section, you get all the sub options within that. That's taxonomy, the categorization of it. From a risk perspective, you have purpose. Here, the typology is type, which is identify different types of risk. The taxonomy is organized risk in a hierarchy structure. In focus, the typology is nature or behavior of the risk. When you look at taxonomy, it's relationship and categorization of risk. When you come to example, when you say typology, it's like we face 6 types of AI risk. Taxonomy, those 6 types fall under 3 main domains. That's taxonomy. The output from a typology perspective, list or grouping or types by types. In taxonomy, hierarchical trees. If you remember, hierarchy is good enough to put up the whole story on taxonomy. So typology, it tells you the kind. Taxonomy tells you how those kinds fit together. Purpose of a typology. AI risk is multifaceted. Technical, ethical, operational, and systemic are its constituent. To manage it coherently, enterprise need a taxonomy, a classification that organizes risk source, its impact domains, and its control levers. A clear typology transforms fragmented vigilance into a structured assurance. It helps define ownership, it helps define to select your controls and design escalation pathways aligned with enterprise risk management. Taxonomy design logic. Drawing from various sources, AI risk can be arranged along with 2 intersecting dimensions: risk domain and risk types. Where the risk originates is what the risk domain is. It could be data, model, operations, governance, or society. How that risk manifests itself through biases, through drift, through misuse, through misalignment, or systemic failure is risk type. This dual axis supports layered accountability. Model level controls for engineers. It supports operational controls for managers, and it supports policy level oversight for boards. So these 2 intersecting dimensions are critical when you look at AI risk. The domain where the risk originated and the type, that is how that risk manifested itself. Let's look at the primary domains of AI risk. Well, it has six: data risk, model risk, operational risk, ethical and societal risk, governance and regulatory risk, strategic and existential risk. Let's go deeper. Data risk arises from data used to train, validate, and operate an AI. Biases, representativeness gap, data poisoning, privacy leakage are the representative risk in this space. Model risk stems from the algorithmic or architectural behavior of the AI systems. This is having a lack of or missing explainability, a lack of or missing gaps in this robustness. Adversarial vulnerability or hallucination represent these type of risk. Operational risks, these are linked to deployment, monitoring, life cycle management, and change control. In here, you have model drift, integration errors, or unapproved model usage. These represents operational risk. At ethical and societal risk, these are consequence to fairness, accountability, sustainability, and social trust. In here, you have discrimination, misinformation, labor displacement, or energy impact. These are risks representing ethical and societal risk. Governance and regulatory risks are failures in oversight, gaps in documentation, and misalignment to compliance. In here, non-conformance with AI Act or DPDP Act or local regulations, opaque accountability chains are representative of risk in governance and regulatory space. At strategic and existential risk perspective, high-end systemic or control loss scenario from recursive improvement. In here, unaligned autonomy, runaway capabilities, or concentration of power represents risk in strategic and existential domain. Let's look at functional topology. Or before that, we have 8 major risk categories. The first is bias and fairness risk, which is systemic distortion of outcomes towards or against a demographic group. Example, credit scoring disadvantaging certain profiles. That's addressing the bias and fairness risk challenges. Here the primary control is or can be implemented is data audits, having fairness metrics, and having a clear bias dashboard. The next is explainability risk. It's the inability to articulate how outputs were derived at the first place. This is like a black box loan denial which violates regulatory explainability. To address this, you have controls such as SHAP, LIME models, or interpretability review. That's explainability risk. The next is robustness and drift risk. This is about model performance degrading over time or under perturbation. The context here is fraud detection accuracy dropping post market changes or over a period of time. To address this, we can have a control of continuous monitoring or retraining trigger points. Example, retraining the base data every 3 months, 6 months, or a year based on how you are able to detect the accuracy misalignment or when the accuracy drops below a threshold. There's something for a thought for the management of the organization to think through how would you track degradation of performance. Do you have a performance metrics around this? The next is security risk. It's adversarial manipulation or theft of a model or a data asset. Could be prompt injection or model exfiltration via API. Here, the primary controls could be red team testing, enabling access controls, or watermarking. Privacy risk. These are unintended exposure or inference of sensitive data, which could cause leakage of customer data in generative prompts. Here, the primary control could be having a differential privacy in place, or federated learning model, or data minimization policy. That's privacy risk. Coming on to compliance risk, it's a breach of AI specific or data protection regulations. Example, being non-compliant with DPDP or GDPR transparency clauses. In here, you can have your primary control around legal mapping, enabling audit logs, and model cards. Next, reputational risk. This is about getting a public backlash from perceived unfair or unsafe AI. Example, from a definition perspective. Could be caused by due to viral complaint on biased insurance pricing. Here the primary controls could be having a responsible AI communication and having a transparent incident disclosure to the regulators or anyone who matters to control backlash. Next is systemic or existential risk. This is about large scale disruption or loss of human oversight. Example, autonomous trading cascades triggering market crash, possible in today's context. Here the primary control is evaluating your capabilities or containment architecture being designed early on or having a policy gating in place. Let's look at inter-level linkage. Micro, meso, macro. What's this? At a micro level, which is level 1, the focus areas are algorithms and data quality. Risks in this are biases, drift, and robustness. The mitigation approach could be testing, explainability enablement, or retraining pipelines. At a meso level, the focus is processes and governance. The risk is accountability, policy non-compliance. The mitigation approach for this could be having an AI risk register, having a model governance committee in place. At a macro level, which is society and economy. The focus area is systemic impact. The risk here could be misinformation, inequality, sustainability aspect. The mitigation approach for this would be having regulations alignment, ensuring transparency, that mechanism should be in place, and providing oversight to your multi stakeholders. These levels are nested. Weakness at the micro level propagates upwards, while stronger macro policies reinforces safe micro level designs. It's a two ways. So when we say weakness at a micro level, means weakness at your algorithm and data quality would impact your meso, which is organization, would impact your society. From the other side, if you have a strong macro policy, top down approach, if you have alignment to regulations, clear transparency policies, and providing oversight feedbacks to your stakeholders, that would drive your process and governance, which in turn ensures that your algorithm and data quality aspects are taken care and factored in. So it works both ways. Let's look at the taxonomy, hierarchy part of it. So AI risk universe, the level 1 is model and data risk. It has biases and fairness, constitutes biases and fairness, explainability, robustness and drift, security and privacy. At level 2, you have operational and governance risk, which constitutes compliance, reputational and life cycle management. And at level 3, the systemic and strategic risk, you have societal impact, existential control failure, and environmental externalities. Each level feeds the next, forming a cascade model. A small defect in data curation can evolve into a public trust crisis if left unchecked. Let's look at an interesting space here. Risk amplifiers. New terminology. Let's try to understand. In AI, there are 5 conditions which exacerbates AI risk. It is opacity, autonomy, diffusion, interconnectivity, and scale. What are these? We look at it in detail. It's important to know these amplifiers demand proportional control intensity. Individual amplifiers. The word amplifier, it means it amplifies the risk in AI space. The higher the autonomy and scale, the stricter the gatekeeping is required. Let's go deeper and try to understand the context of an amplifier or the statement. Amplifiers like opacity, autonomy, diffusions, interconnectivity, and scale demand proportional control intensity. The higher the autonomy and the scale, the stricter the gatekeeping. It means as AI systems become more autonomous, widespread, and complex, we must apply stronger and stricter governance controls. In simple terms, the more freedom, reach, or influence an AI system has, the more careful monitoring and restriction it needs. So let's go deeper. We take the first amplifier, opacity. It means the system's inner logic is hard to see or explain. In AI context, the deep neural networks which makes decisions that humans can't fully trace. Because of it, it's harder to detect biases, errors, or manipulation. That's the opacity amplifier. Think through. When you don't know why a decision was taken, the system is not able to explain to you or it's very difficult to understand. That's an amplifier. The next amplifier is autonomy. Means the system acts on its own without any consent or human control. Context? Think through. Self-driving cars, trading bots, or chatbots operating 24/7. In here, the risk increases because mistakes can spread fast before human intervenes. Think through, you are in a self-driving car. A small mistake. There is no time to react, causing immense danger to the human inside. The next amplifier is diffusion. Technology today spreads rapidly and becomes widely used. Just look through the recent announcements of various new apps. The moment it's announced, 1 million download is already in play in 1 hour or more. So that's diffusion. Today, generative AI models like ChatGPT, DALI are used by millions. And if there is one flaw, it could affect millions instantly. That's diffusion. Next is interconnectivity amplifier. Means it linking many other systems or data sources together. That's how AI works. Connecting. In an AI context, AI integrated with social media, payment, logistic APIs. That's the reality of today. So when a failure is there in one part, it quickly cascades across the networks, increasing the risk. Hence, interconnectivity is one of the main amplifiers. Then we have scale as the next amplifier. The size, the reach, the speed of the system. In AI context, global cloud-based AI services or large foundation models which are currently in use. If there is a large scale error, there is a large scale impact. These properties don't just increase capabilities, they amplify the consequences. Hence, they are called as risk amplifiers. Now, the next statement was proportional control intensity. Remember that statement? Proportional control intensity. The amplifier demands it. What does it mean? Well, it means controls should be stronger, more frequent, and more independent as AI systems becomes more capable or autonomous. That's proportionality, matching the control strength to the risk exposure. Example, a small AI tool recommending songs, it requires a lighter governance. Whereas an AI diagnosing patients or approving loans requires stricter governance. And autonomous trading or weapon system requires maximum gatekeeping. That's proportional control. And this is called the risk-based approach. Similarly, the higher the autonomy and scale, the stricter the gatekeeping. What does it mean? It means when AI systems can make more decisions by themselves and affect more people or system, then human must apply tighter approvals, deeper auditing, and have more fail-safe controls in place. Think of gatekeeping as the governance checkpoint. Gatekeeping is equal to governance checkpoint. It's a checkpoint. It has approvals, it has audits, it has explainability reviews, ethical sign off, and red teaming. This ensures AI acts responsibly before being released. You're not releasing without these checkpoints. While it is difficult today with the excitement of new AI tools coming every day and the pressure to come to the market early on, organizations might cut corners or might not see in worst case scenario the benefit of these checkpoints. But trust, not doing it causes a lot of damage, or if not done already, it is bound to happen. It's only a matter of time. So think through whether you have these gate points today in place. Do you have the right approvals? Are there audits inbuilt or have a process in place? Do you have an explanatory review already in place? Are there ethical sign-offs in place? Is there a red teaming for this to test around? Key takeaways. Well, AI power comes from its amplifiers. Do note, amplifiers gives what AI is today, but also it comes with checks and balances. Each amplifier adds capability and also adds risk. Therefore, controls must scale with capability. Governance isn't static. It's adaptive and needs to be proportionate. The smarter the machine, the wiser the gatekeeper must be. Let's look at ownership and accountability. So at a data owner level, the primary responsibility is maintaining data quality, maintaining lineage, and consent. This could be delivered through data governance register. Technical performance and documentation comes from model owner and developers. This could be achieved through model cards and validation reports. Independent testing and alignment checks comes from model validator or the AI risk officer. It's their primary responsibilities. This could be achieved through risk assessment report. Ethical and regulatory compliance in use cases, the role is played by or should be played by the processor or the business owner. That's their primary responsibilities. This could be achieved through AI use cases, risk logs, and finally, having an oversight, ensuring policies are in place and risk appetite is defined clearly. This responsibility lies with the CRO or the board committee. This could be delivered through AI risk policies and having a clear dashboard. This matrix operationalizes insight that institution design is a safety feature. Now, pausing here, think about your own organization. Where do you stand and which roles are currently performing what function? Are they aligned? Or are there roles which are missing? Because if it is missing, then you have to check whether the responsibilities are they also missing or it is done by some other combination. It could be, worst case scenario, it could be one person doing all of that. You have trouble in hand. Having said that, this is a model that has been proposed but doesn't mean that it has to be is applicable for your organization. You have to think what makes sense for your organization, what's practical, feasible for you. But having a look at the responsibilities, whether the data quality, maintaining lineage, consent, having technical performances, documentation, independent testing, all these are non-negotiable or should not be negotiable. It should not be a good to have, it's a must to have. So these are designs, and these designs are not for show, these are safety features. These in future would allow you or help you to stay outside the jail, because things are getting difficult, regulations are becoming tighter, penalties are higher, and these are extremely powerful technologies, could be used and misused. So if misused and it's your, you have to think through having these institutional design make sense or not. Moving on. So what does institutional design, why? What does institutional design is a safety feature mean? What does it mean? Well, it's how an organization is structured. Who owns what? Or who approves what? Or who monitors what? Structured organization is itself a form of safety control because of these three. In other words, good institutional design prevents bad outcomes. It's not just people or policies that keep AI safe. It's the way we design the institutions around the AI. Important is have a clear defined roles, responsibilities, reporting lines, incentives, decision checkpoints. That design acts like a built-in safety systems, much like airbags in a car or circuit breakers in electricity. Think through what will happen if you don't have those airbags in your BMWs. So these are your safety systems. So when we say institutional design, we mean how AI governance committees are structured, how roles like CRO, CDO, CISOs, and AI ethics officer interact between each other, how the decision flows from approval to escalation to managing exceptions, how accountability is distributed and not blurred. This design decides whether issues are caught early or missed entirely. Now, if the structure is weak or siloed, risk slips through. And if the structure is clear, multi-layered and empowered, it functions as a risk control system in itself. In summary, from perspective of an AI risk ownership and accountability metrics perspective, you have the strategic layer. Primary role is to have an oversight and risk appetite defined. The focus is set ethical, legal, and risk boundaries for AI. That's your board and the CXO. At a tactical level, your role is to have control ownership, where you focus on implementing the policies, frameworks, and monitoring. This is where the CRO, the CIO, the CDO, or the CISO would be based at or mapped at. At an operational layer, the primary role is to execute the controls. The focus is to build, test, and deploy models safely. This is where your developer, your data scientists, and the product owners should be mapped to. And finally, you have the independent assurance aspect. The role is to validate what has been declared at each layer. The focus is to verify that the controls and the governance actually work. Each defined role, reporting lines, and control checkpoint is a safety mechanism that prevents AI systems from running unchecked. Let's take an analogy. First, let's take an airplane analogy. Now, airplanes have multiple redundant systems, not because pilots are careless, but because safety comes from design, not luck. Similarly, AI governance shouldn't depend on individual heroics. It should be institutionally designed so that checks and balances are built in and not bolted on later on. Similarly, let's take a banking analogy. Now, banks survived the financial crisis when their risk committees, their internal audit, and their regulatory reporting lines were strong and independent. That's institutional architecture was their safety feature. AI needs the same kind of architecture to prevent ethical or operational crashes. Now, in an AI governance context, institutional design covers who approves AI use cases. This is your gatekeeping layer. Institutional design covers who validates data quality and biases. This is your quality assurance layer. The design covers who audits the model periodically. This is your assurance layer. It covers who escalates ethical concerns. This is your accountability layer. Each of those is a circuit breaker. Yes, a circuit breaker. That means if there is no approval, if things are not in place and your gatekeeping layer is working, it breaks the circuit there. It doesn't allow those issues to move further. If the first one approves it, but by validating data quality and biases are identified, your quality assurance layer checks and stops it there. That's a circuit breaker at layer 2 and so on. It is doing it to prevent systemic failures. Do you have it in your governance context for your organization? Do you think this add value to you? That's a thought for you to take from this video. Now reflect institution design in an AI risk accountability matrix. Model bias, CDO and ethical officers are accountable. These are independent model review boards. For explainability, the product owner is accountable. The feature is for mandatory transparency checklist. For model drift, the CRO is accountable. For data privacy, the CISO is. And systemic oversight, the board is. A well designed institution makes safe AI because accountability and not algorithm is the first line of defense. Yes, accountability is your first line of defense, not the algorithm that has been thought through in many of the organization thought process. To achieve enterprise consistency and regulatory interoperability, you would need to adapt ISO or IEC 42001 taxonomy as a base, or you can map to NIST AI RMF functions, which takes care of governance, map, measure, manage aspect of it. And you can link risk type to controls in internal ERM or model risk management. That's the framework. And finally, use standardized tags in model registry. Well, this creates traceability between the technical and governance artifacts. And it's an expectation under the future AI Act audits. Now, what do we mean when we say in AI risk management we need to create traceability between technical and governance artifacts? And it's an expectation under future AI Act audit. Well, in AI risk management, we must be able to trace every governance decision. Why, who, and when should be able to map to technical evidences of what and how. Similarly, the what and how, the technical evidence should be able to map to who did it, why it was done, and when it was done. We need to be able to trace every governance decision back and forth. That traceability creates a visible, verifiable link between what the AI system does and what the organization promised or was approved of or documented in their governance term. Now, this linkage will soon be mandatory under laws like EU AI Act, especially during compliance audit. Do note, you are watching this video, one of the many reasons is the regulations are coming hard and fast at a very wide brush. Now, this one aspect is going to be a recurring theme when you are managing your AI space. You should be able to trace why, who, and when with what and what and how should be able to be traced back to who, why, and when. And this need to be linked to what you promised as an organization, what was approved as an organization, what's documented in your organization. All of these should be in a straight line or clearly linked. Any missing link or anything which can't be traced back or explained or a deviation is a serious concern, especially during your audits. The stakes are huge. So you can take the screenshot of this screen and check this aspect for your current AI governance structure. Do you have it or what's missing? The next is, what are technical artifacts? We discussed this earlier. What are technical artifacts? Well, these are evidence objects that come from the AI system and its development life cycle. When we say model card, it means the summary of what the model is, its purpose, its limitation. Here the artifact is accuracy metrics. Do you have it with you? Data sources. Do you know everything about the source? And do you have a performance score? That is what would be expected to be provided during a review or audit, or as a management, you should be asking this to your team managing your space. Accuracy metrics, data sources, performance scores. The next technical artifact is data sheet. These are records of data lineage, where it has come from, its source, and its quality. Example of these would be training data sheet info, processing steps, how it was processed. That will give you the lineage. The next technical artifact is bias or fairness test report, meaning it's evaluation of biases in model output. Here, the artifact would be fairness scorecard. or accuracy of the subgroups. The next technical artifact is explainability report. Means show how decisions were derived, how the conclusion was arrived. That's what this means. Here, the artifacts would be shape and line plots, model reasoning logs, etc. Then we have drift logs, which is evidence of model changes over time, or retraining record drifts alert. These exist mostly with data scientists, ML engineers, or DevOps team. Time to review. Is this where it should be, or should there be a change? So that's the technical artifacts. Let's now look at the governance artifact. Well, these are management, compliance, and oversight records owned or supposed to be owned by risk, compliance, or audit teams. In an unstructured organization, this might be mixed up with others. Governance being held by technical team and technical team holding the governance one. It's time to clean up the act, put the house in order. Let's go through the governance artifacts. The first one is AI policy and framework. Means the rules, the standards for AI governance. This is where responsibility of the AI charter is defined or internal risk policies are set in place. Next is risk register. This is a list of all known AI risk and mitigations. Example, biases, privacies, explainability risks are logged in. The whole dump. Next is approval minutes. These are record of governance or ethics committees decisions, also known as minutes of the meetings. Example, AI use case review board approvals and so on. The next artifact is audit reports. Could be internal or external audit findings. Example, compliance and assurance documentation. The next one is the RASI or the accountability metrics. Who is responsible for what? Example, role-based accountability chart, the whole map, organization map when it comes to AI. These are non-technical documents. They express accountability. So why the EU Act will require technical artifacts and governance artifacts? Well, under the EU Act, expected enforcement in 2026, high risk AI systems, could be credit risk scoring, health records, employment, etc., must keep a comprehensive technical documentation. It's a requirement. Organization must show conformity assessment evidence linking the governance intent to its implementation. During any audit, or regulators will ask, yes, they will ask, show me how your AI ethic policy connect to this model's training data. Show me how your ethics policy connects to the performance metric and deployment logs. Show me the evidence. Now, if you cannot link your policy statement to system level artifacts, it's a non-compliance finding. So, the EU AI Act essentially enforces traceability as an audit control. Do note, traceability as an audit control is a requirement in EU AI Act. For those who want to know about EU AI Act, there is a separate video in my series. You can have a look into this and go deeper into the subject if that helps you. In AI risk management, traceability is the bridge between intent and implementation. Yes, traceability is the bridge between intent and implementation, and future AI audits will walk across that bridge. So, well defined taxonomy is not academic, it's a risk compass. It allows organizations to prioritize controls based on risk, class, and impact. It allows organization to align cross-functional ownership, and it allows organization to create reusable reporting templates for auditors and regulators. Taxonomy is the map, the foundation on which the rest of the AI risk governance is built. Now we can finally see the battlefield clearly. Bias, drift, explainability, security. They are not random failures but predictable patterns. A shared taxonomy gives leader a common language and an engineer a clear checklist. With that foundation, we can move from reacting to surprises to designing for safety. Up next, let's see how global framework turn these categories into structured governance. With this, we have come to the end of part 2. We'll be moving to the next part 3, wherein we'll cover frameworks and standards in AI risk management. I'd like to thank you here for the time that you have invested. This is your host, Savit Vittal Salian. Namaskar.